exponential growth functions. And by the way, when we get to lesson 8.6, we will study exponential decay functions, okay? So growth and decay. But today, we will be studying exponential growth functions. Your heading for today is exponential growth functions. Please write that down, lesson 8.5, and be sure to include today's date, alright? I'm going to go fast through this video, so anytime that you need to stop the video, just pause it, and then restart it when you're all caught up, okay? Now, a quantity, I would write this in your notes if I were you. A quantity is considered to be growing exponentially if it is increased by the same percent or multiple per each unit of time. I would write that down, okay? When this occurs, we have what we call exponential growth, okay? Now again, I'm going to move on. Just pause the video and then restart it when you're able to. Those last two sentences right here, there's two sentences right there. Those last two sentences can be confusing, so let me give you some examples that will help you understand what I'm saying, okay? Please watch carefully. You can take notes or just watch, it's up to you. If I have 2, and then 4, and then 8, and then 16, and then 32, and then 64, that's an example of exponential growth because my quantity, a 2, increased by the same multiple. I multiplied by 2, 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 etc. Does everybody see that okay? Does everybody get that? Alright. Now, you could also look at this as a percentage. Please watch carefully. Each one of these increased by well, actually that's incorrect. We had an increase of... Okay, students, I'm back. I had to pause the video. I'm not sure where I left off at, but what I was saying is this here. It's not correct. It's not a 200% increase. Watch carefully, please. Please watch. If you don't watch this, you're going to be confused. My multiple is 2, like I already showed you, okay? So we're increasing by the same multiple. We're also increasing by the same percentage. Please watch. I start off with 2, and I increased by 2. That's 100%. Then I have 4. 4 is my new 100%. I increased by 4 up to 8. That's 100%. I went from 8 to 16. I increased 8. That would be 100%. I went from 16 to 32. So 16 is what I have. I added to it 16. That's 100%. I get 32. I have 32. I add to that 32, which is 100% of 32, and I get 64. So no matter what way you look at this, it's increasing by the same percent or it's increasing by the same multiple. Either way, we have exponential growth. Do you see it okay? If not, back up and watch that again. I'm trying to show you with an example what I was saying up here. You have a quantity that's increasing by the same multiple or increasing by the same percent every time. Okay? Alright, moving on. Now, here is the basic model that we use for exponential growth. Okay? The basic model. Please copy this in your notes. Now, I'm going to go through quickly and show you what each variable stands for. Okay? I'm going to go fast, so you'll probably have to pause the video a lot. Okay? But here we go. The y is your ending amount. That's what you end up with after you're totally finished with the problem. C is your initial amount. Okay? Your initial amount. Now I need to stop and show you something you need to know. Okay? Please listen carefully. Well, I know I'll come back to that later. Let's just move on. Okay, 1 plus r, that entire thing together is called your growth factor. Your growth factor. R is called your growth rate. Your growth rate. And T stands for time. Okay, time. Now, having gone over all of that, let's take this model, let's apply it to some problems. Before I do that, I need to show you something really, really important. This is going to be really, really confusing if you don't listen well. Remember my first example I gave you? I had 2, then 4, then 8, then 16, then 32, and then 64. Remember? Well, if I added all of these up real quick, just for the fun of it, again, just watch. What would I get? Let's see. 6, 14, 30, 62. I think you get 126, but I did that pretty quickly. 96. 112, 20, yeah, 126. Okay. Everyone focus. When you take a model like this, what would your C be? Remember what C is? Your starting amount. So C would be your what? 2. Now a lot of students would think this model here, your ending amount is Y, right? Everybody listening, look at your notes. They would think that your ending amount would be what? 64, because that's your last number, right? That's incorrect. Your ending amount is 126. So what this model does for you is it gives you the sum of all of the numbers in the problem. Do you understand that? It is paramount. It is imperative that you understand that. So when I say starting amount, that's the amount you start off with. When I say ending amount, that's the sum of all of these numbers added together. Got it? It's very, very important you understand what those two numbers, what those two variables are, and what they mean. Okay, moving on. Now, in your notes, I would not take time to write this down. I would just write page 477, example number 1. Okay? I would not write this problem down. It takes too long just to write page 477, example 1. And here we go. You deposit $500 in an account that pays 8% interest every year. Okay? Compounded yearly just simply means you get interest every year. If it said compounded monthly, that would just simply means they figure your interest every month. Okay? The more times you get interest, the better off, the more money you're going to have. Okay? So, I start off with $500. Got it? I'm increasing it at 8% interest rate every year. What is my balance after 6 years? Now, you can do this the long way and do a bunch of multiplication over and over and over. It would take a long time. You have to take 500 times 0.08, and whatever you get, then add that back into your 500. Okay? I'm not sure what you would get. Let's see. Let's see, it'd be 500 times 0.08, 40. So you would get 540. Alright? And then take 540 times 0.08, and you would get 4320. So you gotta take 540 plus 4320. Now you have 583.20. You've got to keep doing that up to a total of 6 times. That could take you a while, okay? So, there's a faster way to do it, and here's the faster way. Do you notice we have exponential growth? Guys, you can only use the exponential growth formula, the model right here. You can only use this model when you have what? Exponential growth. Well, Mr. Earhart, how do you know we have exponential growth? Because look what it says. You're increasing at the same what? Percentage every year. What's the definition? When you're increasing by the same percent or multiple. Okay? And we are. We're increasing by the same percentage right here. Every year. So we have exponential growth. So if we have exponential growth, let's use our model. Why wouldn't we? Makes sense to me, I would. So here we go. Why is my ending amount? Okay? So that's what I'm looking for. C is my beginning amount, 500. 1 is 1. My rate is 0.08. Okay? T is time. What's my time? 6. So now I have 500 times 1 plus 0.08, 1.08 to the 6th power, Now, remember, you do not do your multiplication first, you do your powers first. So I've got to take 1.08 to the sixth power and then multiply that by 500. So here we go. So I have 1.08 to the sixth power. Okay, got it? Equals, and then times 500 equals 793.43. And there we go. That's my ending amount. So, if I asked you, are you listening? If I asked you for your final balance at the end of 6 years, you would say this is how much you have. If I asked you how much money did you gain, you would say you gained $293.43, right? Because you started off with how much? 500. You ended up with how much? 793. That's $293 more than 500. So always listen carefully to what I asked for. If I asked for how much money you gained, or if I asked for the interest, how much interest did you gain? You gained that much interest. What's your final balance, your final amount? This right here. See how quick that formula is, guys? That's so much faster than doing that one thing I showed you 6 times, doing it over and over and over 6 times. Okay? This is a really helpful model. Ending amount, initial amount or starting amount, rate, time. Got it? Okay, moving on. Now, this is going to be a little harder because now we're dealing with a percentage instead of a multiple. Okay, well, I'll show what I mean by that in a second, okay? Here we go. A newly hatched, by the way, this is channel. I would not copy this problem in your notes, okay? I would just write in your notes, page 478, example 2. Alright, here we go. A newly hatched channel catfish typically weighs about 0.3 gram, alright? 0.3 of a gram. During the first 6 weeks of life, its growth is, look at this, exponential. The growth is exponential, so we know we have exponential growth because the problem is telling us that we have exponential growth. It's increasing by about 10% each day, okay, for the first 6 weeks. Got it? So let's write a model for the weight during the first 6 weeks. Okay, here's my model. Y equals C. Now watch carefully, please. 1 plus r to the t power. Got it? Now, C is my initial amount, which is 0.3. That's how much the fish weighs when it's born, okay? Or hatched. My r is going to be 0.10 because remember, 10% is 0.10. I should have mentioned that in the last problem. 8. Change it to a decimal, move the decimal 2 places. 0.08. Alright. Now t, of course, is my time. So there's my model. I did it. That's it. That's it. Now, some students would want to put, let's see, it says they gain 10% each day. Do you see that? And we're dealing with 6 weeks. So how many days are in 6 weeks? 7 times 6, 46 days, right? 42 days. So some students might want to put a 42 here. If you did that, I have no problem with that. That's fine. If you put a T there, I have no problem with that. Okay, I don't care. Either way is fine. Alright? Now, we take this model right here, and we find the weight at the end of 6 weeks. So here we go. There's Y. There's 0.3. There's my 1 plus 0.10. And of course for T I would put what? 42. Because I want to find the weight at the end of 6 weeks. Mr. Earhart, why didn't you put a 6 right here? It's for 6 weeks. Because read the problem carefully. It says that they're increasing 10% per week. No, 10% per day, each day. So this 10% is a daily increase. So you must have your time in days. Now, next I would say Y equals 0.3. 1 plus 0.10 is 1.10 to the 42nd power. So here we go. 1.10 to the 42nd power equals times 0.3 equals 16.43. as you can tell, it grows pretty quickly. Alright, it starts off just weighing zero point 0.3 of a gram, and it ends up weighing 16.43 grams at the end of 6 weeks. Okay? Alright, let's move on, guys. Here we go. Please pay close attention. Be careful now. Here we go. This next problem could be tricky, so watch carefully. And actually, I mentioned earlier this problem here would be tricky. I was incorrect. This is the one here is going to be tricky because this problem here dealt with a percent. This problem here dealt with a percent, but this problem here deals with a multiple. It's tripling, so it's going to be a little confusing. So I need you to really hang with me and think about this, okay? Here we go. The population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. What is the percent? Boy, I'll tell you what, my typing was really bad. I do know how to spell. What is the percent of increase each year? Now, please be careful. You're going to think that it's 300% if it's tripling. And that's not correct. I would like to show you why, okay? Just watch this example, please, okay? Alright, here we go. Let me give you an example of something tripling. Are you ready? There. Now, don't write this down, just watch. Times 3, times 3, times 3. Everybody with me? So this is an example of something tripling, okay? But hold it. Watch carefully. I multiplied by what number? 3. But my percent of increase is 200%. Let me show you how I got that. Okay, watch. What do I add to this to get 9? 6. What do I add to this to get 27? 18. What do I add to this to get 81? 54. Now watch. I started with 3. That's my 100%. But I added how much? 6. That's 200% of 3. If 3 is 100, that's 200%. Here's my 9. That's my 100%. I added to that 18. That's twice as big. That's 200%. Here's my 27. That's my 100%. I add to that 54. That's twice as much as 27. That's 200%. I'm not asking you to understand everything I'm doing. I'm just trying to show you where I get this from. So the percent of increase is 200%. Now, would you like a fast way to do this? So you don't have to do all this math. I can show you a quick way to do this, okay? Whatever the multiple is, in this case it was a 3. Always subtract 1. Always subtract 1. And then change it to a percent. So 2 equals 200%. That's a fast way to do it, okay? Always subtract 1. So if I told you that a number was being, if we had a group of numbers being multiplied by 5, multiplied by 5, okay? So the multiple is 5. What's the percentage? 400%. Subtract 1 from 5, that's 4. And then change 4 to a percentage, move the decimal twice, 400%. That's a nice, easy, fast way to do it. Do you understand? So when we're dealing with exponential growth, there is a difference between percentages and multiples. Make sure you understand that, alright? By the way, if I gave you a percentage, and I asked for you to show me the multiple, then just go backwards. If I told you the percentage is 200%, and I said, what's the multiple we're using? Well, 200% is the same thing as what? 2. And then add 1 and you get 3. So you're adding 1 to find the multiple. You subtract 1, you're trying to find the percent. It's not that difficult, okay? So here's my example. I've got rabbits that are tripling in their population. What's the percentage of increase? Take your multiple, subtract 1, what do you get? 2. Change that to a percentage, and there's the answer. It's a 200% increase. Got it? 200% increase. Now, what's the population after 5 years? Well, we know we have exponential growth because we have a multiple or a percentage that's the same every time. So we know we have exponential growth. So we can use our nice, fast, handy, dandy formula. So why is my ending amount My starting amount is 20. My rate is, now be careful, it's 200%, so I put a 2. Okay? How do you write 200% as a decimal with a decimal 2 places? Is 2. My time is 5 years. Now 1 plus 2 is 3, so I have 20. 3 times 3 to the 5th power. So I have 3 to the 5th power times 20. And in just 5 years, you have 4,860 rabbits. And by the way, rabbits are known to reproduce very, very quickly like that, okay? So there's your population. I hope I did not lose you or confuse you, okay? Let's review very quickly. If I told you that a quantity was being increased by a multiple of 4, and I said, what's the percentage of increase? You would subtract 1 from this, and then change that to a percentage. 300%. Got it? Now let's go backwards. If I told you something was being increased by 18%, and I said, find the multiple. Got it? Find the multiple. Okay, no problem. We're going to, first of all, convert it to a decimal, 0.18, and then if subtracting 1, we add 1, so the multiple would be 1.18. That's it. Okay, so if I gave you a multiple like 4, and asked for the percentage, it would be 300%. If I gave you a percentage and asked you to tell me the multiple, you add 1, it's 1.18. Go over this and over this until you understand it, okay? That's all for today, students. I hope this video has been a help to you. We've been dealing with exponential growth. We will get into exponential decay, hopefully in our next video. If you have any questions, don't hesitate to call or email.